And that, my friends and foes, is the past 24 hours of the northwestern limb of the closest star. And by the way, thanks for tuning in to the Daily Space Weather. And thanks for realizing the Smash News Network least busted name in news indeed exists. Filaments are the story of the day. Also, we would take the opportunity to admit when we are wrong. Yeah, we were wrong about the CME impact. It was indeed going the opposite direction, not toward Earth. And if you're not willing to be wrong in science, then you're not doing science, you're doing dogma. And you're certainly not cutting edge if you're just spouting a bunch of talking points. We're trying to advance heliophysics and, as a result, cosmology. So again, the story of the day is filaments, and you can certainly see quite a few of plasma filaments. These are, such as this prominence up here, areas where there is massive amounts, billions of tons of matter suspended by the sun's magnetic fields, defying gravity. Superhot plasma there consisting mostly of hydrogen nuclei. And these filaments do have the tendency to eject in an event known as a coronal mass ejection, where they go flying off through space, and sometimes causing aurora at the Earth. We do have a new active region rising here in the southeast. It could be a sunspot. Let us know in the comments what you think. Do you think it's a sunspot, or do you think it's a sun knot? Also, in the last 24 hours, a prominence down here in the southwest. So, yeah, that's the story of the day, is solar filaments. And you can see lots of solar filaments roiling around in different locations, like the Bill Gates filament here, the David Lee Roth filament up here. We've been naming filaments after living people on Twitter, so make sure you follow the hashtag over there, hashtag #NameThatFilament. There's the full disk view. These are 304 plus 193 angstroms wavelengths from SDO. And that is a great couple of wavelengths through which to view filaments. Let's take a look at sunspots. We do have a new sunspot here forming and then sort of evaporating. That's yesterday plus today. So you've got some spreading apart of these umbrae in this southern sunspot down here. That's the most likely place to see any large flares. A little bit of growth in this group up here. So we may have a couple new named groups here. It looks like this sunspot right here might get a name. Besides that, things mostly stable over the past 24 hours. Let's show a little more detail with the colorized magnetogram. That is also yesterday plus today from SDO. And if you enjoy the content, please support the channel via our links. Smashomash.com is our homepage, so visit us over there. You can find links to the social media, merch, and lots of other stuff like the Smasho forum. That stuff is all built for you, the viewer. So please utilize the resources that we've painstakingly created. Today's featured product is do not pole vault the caldera. Yeah, don't pole vault the caldera. No matter how bad things get, they can certainly get worse. And your pole vaulting the caldera is not going to help things. So, I mean, I'm wearing it today. Like, I would never put out merch that I'm not willing to personally wear. So, there's my Do Not Pole Vault the Caldera shirt. So check out the merch. You can find links below the video as well as on the homepage at smashomash.com to the Smasho merch. I think there are 32 different designs there and all kinds of different products. Whether you're looking for a new dress or a pet bowl, we've got you covered. And you can also find links to the Hemp Lucid shop, our latest affiliate/sponsor. So check out those products. The most popular are the CBD tinctures. You can also find mushroom gummies. If you want to try the free mushroom gummies, well, you can find a link on the Twitter feed. And thanks to everybody who's picked up merch and products from Hemp Lucid. Let's get back to the Daily Space Weather Report. So next we're looking at volcanoes here. We're always interested in what's erupting on the Earth side of things. So Crescent Earth here featuring Some volcanic eruptions indeed, like Bezimiani, continues to explode here and produce a 14,000-foot plume of volcanic ash, otherwise known as a Flight Level 140. Flight Level 100, 10,000-foot ash plume over Paramushir Island from Abiko. Semeru erupting, Flight Level 140 over Semeru. And now Taupo. Oh, check it out, Taupo. Seismic unrest lasting for 10 months. Although, starting early this year, a decreasing trend of seismic activity under Taupo. It has been reduced to level green. So we reported about a couple of weeks ago about Taupo looking like it was dropping in activity. Indeed, it looks like it is. Popocatépetl exploding, Flight Level 220 over central Mexico. That's a 22,000-foot ash plume. 15,000-foot ash plume over Fuego in Guatemala as Fuego explodes. Nevado de Ruiz, mild explosive activity. Please don't pole vault the caldera. Sangay in Ecuador exploding, Flight Level 240. That looks like an uptick at Sangay. Revenador, Flight Level 150, 15,000-foot ash plume. Cotopaxi also erupting in an explosive fashion in that same nation. 22,000-foot ash plume. 25,000-foot ash plume over Sabancaya, located in Peru. We saw 2 6-magnitude earthquakes over the past 24 hours, one in the Philippines and one at Panama, actually. So there's the past 90 days in a convenient bar graph form for you from Volcano Discovery. The first quake we'll highlight here is this 6.2 at the Philippines. That came in at 12:54 Universal Time yesterday. There is the location of that in the extreme Western Pacific. There was also a 6.3 off the coast of Panama in the extreme Eastern Pacific. So significant earthquake uptick here in the past couple of days. There's a location of that Panamanian quake, and let's scroll up the list here, citing quakes over a 5 magnitude. So lots of activity there around the Pacific Rim, especially. Tunisia also had a 5.0 there, around the southern coast of the Mediterranean. Also, the Nicobar Islands near India had a 5.0. Chile had a 5.9. And again, there was that 6.3 at Panama. That came in at 22:18 Universal Time yesterday evening. Also another 5.4 there at California. So just a quick reminder, folks, any earthquake can be a foreshock. And if you're signed up for email alerts, you will get email alerts about things like tsunamis and space weather. You can find all of that stuff at smashomash.com/smash. And we even send out email alerts about the releasing of videos like these because many people do not trust certain organizations to provide notifications that we've put out content. Anyway, there's also a 5.1 in Brazil there. That one coming through at 6:19 Universal Time this morning. And let's get back to space. Here's the past 24 hours in SDO 171 angstroms, the house favorite wavelength. We'll also add 131 angstroms to provide some additional detail. Those two wavelengths are great at showing the magnetic field orientation of the lower coronal plasma. So if you see things that look like magnetic field lines there, you are seeing plasma aligning to the fields while emitting ultraviolet radiation. That's what the SDO AIA instrument is doing. It's showing you ultraviolet emissions from the solar corona. And let's talk about some stats. Radio flux now at 136 solar flux units. So the radio flux, for you new viewers out there, and congratulations on realizing the channel exists, the radio flux is the proportional data set that we have to sunspot number. So as you can see right here, for example, you see a huge trough in the radio flux, which is this black line. That's a 1-year graph. And then you see a huge trough in the sunspot number. Likewise, here's another one. Big trough in the radio flux, big trough in the sunspot number. Big peak in the radio flux, big peak in the sunspot number. See what I'm saying here? The radio flux is directly proportional to the sunspot number, and certainly has been since 1947 when it was discovered. Space Weather Enthusiast dashboard here, not showing any geomagnetic storms in the forecast. I would tend to agree. No space weather storms currently on the way. Here's Earth's magnetic moment from space for the past 4 hours. And we show this magnetic data just to show a visualization of the space weather environment. This is depicting magnetohydrodynamic pressure, the units of which are called nanopascals. It's showing you the plasma pressure out to about 12 Earth diameters. We also show the ground magnetic perturbations daily on the channel because there's a lot of nonsense on YouTube about scary, spooky pole shifts. By the way, the pole is much more likely to just snap back toward the geographic poles than it is to reverse or get extremely weak. Those are extremely unlikely circumstances. So we show this daily because if the pole was shifting to the extreme, we would see it depicted in this imagery. We don't because it isn't scary. Next, the Planetary K-index, a measurement of global geomagnetism, an average, if you will. KP index is currently at 2. Planetary K-index of 2, geomagnetically calm conditions. And let's take a look at the real-time solar wind, which is measured outside Earth's magnetosphere out here at Lagrangian point 1. Current conditions are quite uneventful. We've seen a recent downtick here in solar wind speed and plasma temperature. So that looks like the end of a coronal hole high-speed stream right there. When you see the plasma temperature drop off like that, that is usually the signal of a more regular background regime of solar wind. It looks like the coronal hole high-speed stream is subsiding promptly here. Current conditions are about 465 kilometers per second for the solar wind velocity. Solar wind density here about 5.4 protons per cubic centimeter. We are seeing a little bit of an increase of the magnetic field strength and a negative BZ happening here. So we could see a little bit of an uptick in geomagnetism, especially if the field continues to increase. And that red line up there in the top pane by my pointer, that is the vertical component of the magnetic field. And when that swings into negative with a solid signal, that is a formula for more induced currents in the Earth system, hence higher geomagnetism. Next, looking at magnetism from space as measured by the GOES 16 and GOES 18's geosynchronous near equatorial magnetometers. And we're seeing things a little bit smoother here, another indication that the coronal hole high-speed stream is ending. And let's take a look at Earth's plasma environment here. This is the heliospheric current sheet depicted in its magnetic polarity, and Earth is just snapping into a North Pole current sheet. So there's the North Pole current sheet depicted in green, South Pole in red. Sector boundary crossing has likely just been achieved. This data is actually a little bit old here. It's nearly 2 hours old already. So that's our top view ecliptic plane field plot. Sector boundary is just been crossed. Sector boundary has just been crossed. Earth is now in a North Pole current sheet. Here's our line of sight field plot depicting the sun's B field in blue, solar polar fields in green and red for north and south respectively, which brings us to coronal holes. Oh, and a quick side note. We've got a lot of coronal magnetism in the north heliographic pole yet. You see that? Until that leaves there and gets replaced by mostly South Pole magnetism, we've got a long way to go to solar maximum. I'll just say that. Over a year until we reach solar maximum. We're just not there yet. So here's our coronal hole line of sight plot, and you can see that sector boundary crossing depicted here in this blue line. It's this like curved ridge you see right here. That is the sector boundary crossing. Again, Earth has just snapped into a North Pole current sheet, which is probably actually what that sudden change in solar wind was. Anyway, North Pole current sheet here looking a little bit stronger than it was the last time around. So perhaps we're expecting to see some migration of that North Pole coronal hole. In any case, that's the current line of sight plot for coronal holes. And let's take a look at it from the SDO 211 angstroms wavelength. That is yesterday plus today. And what do we have here? Let's bring up the latest image. So we've got North Pole coronal holes here rotating in. So that's North Pole, and we'll see some forming down here also. That these are all North Pole coronal holes rotating in from the east. And let's move to sunspots. One of the other, you could say, rather important features that we cover to show you the in-depth analysis of Solar Cycle 25's progression. So flare probability here, there is still significant probability of large solar flares because this sunspot here, 3270, is certainly quite magnetically complex. So don't be surprised to see a large flare, and as it gets closer and closer to the limit, it becomes more likely to produce a large flare. It's just a statistical reality, and of course it raises the possibility that solar flares, which are X-ray photons, by the way, solar flares could indeed be anisotropic, meaning if a solar flare occurs from a sunspot here, it may show lower intensity than if it occurs over here, which is an interesting insight into the physics of perhaps what stars are really made of. Let's take a look at some sunspots here. Here is SDO continuum plus 94 angstroms to highlight active regions. This region down here, not a sunspot there, but there is likely one rising behind it. That does look like a sunspot there. I see a lot of material suspended, and let's zoom in and lose 94 angstroms. There you should see some great high-res imagery. Again, most of those sunspot groups fairly stable here. No major changes likely coming in the sunspot number. A little uptick in sunspot number, I believe, and at least one new named sunspot group is likely in the northern hemisphere. Next, we'll look at energetic particles and solar flares. So, and, side note, don't get solar flares and coronal mass ejections confused. They are separate phenomenon. Solar flares are photons. Coronal mass ejections are mostly protons. Very different. So stand in front of a fan sometime, right? The wind is going to blow your hair back. Whoosh. That's like a coronal mass ejection. Shine a bright flashlight in your eyes, or go have an X-ray. That's like a solar flare. Very different phenomenon. Photons and protons are very, very different things in the realm of physics. No relativistic particles here showing up on the proton flux. Remember, folks, we don't need solar flares to see coronal mass ejections, and we've got a massive number of solar filaments on the Earth-facing portion of the solar disk. So the likelihood of coronal mass ejections remains at nearly 100%. Here are the past 3 days of solar flares, and seeing a little bit of a modest uptick here since yesterday. I mean, yesterday we were at a B5 background level. Now we're at more like a B7 or B8 background level, something like that. So a little bit of an uptick there in the X-ray flux. No major flares. Again, the likelihood of major flares is certainly still there, especially with sunspot 3270, this group down here. 3270. It's certainly capable of producing large flares. As we analyze the magnetic fields to determine that probability. So that's 131 plus 94 angstroms for the past 24 hours. And let's take a step back and do some astrography. Because before we look at coronal mass ejections, it's great to orient ourselves where we're located with respect to other things. So we're bringing up the star chart here from skyandtelescope.org. If you're up before dawn, you might see Saturn. And if you're up after dusk, you might see Jupiter and Mercury there, trailing the sun on the ecliptic. And I think Jupiter is currently the fifth brightest object after the sun, the moon, Venus, and Mars. Here's your solar system forecast. This is where things are now from this lonely side of the solar system. We'll advance this 1 week. There's where things will be in a week. Full moon coming tomorrow, it looks like, on April 6th. Next, some coronagraphs. And it's been quite quiet as far as coronal mass ejections. Don't expect that to continue. There are a huge number of filaments right in the Earth-facing portion of the solar disk. So there's yesterday's images. Here are today's coronagraphs. And a minor CME there out of the southeast. But besides that, not a lot going on. Let's take a look at stereo A and Soho Lasco C3. Stereo A located right there, just a few degrees behind the Earth, depicted over here on the left, and Soho Lasco C3 located at Lagrangian point 1, the same location we measure the solar wind. Again, things quite calm here, and that is Jupiter, by the way. And let's show some 24-hour videos. There's a 24-hour composite. Only very minor coronal mass ejection activity in the past 24. We like to put 193 angstroms in there because it shows some great features that 304 angstroms doesn't show. It's not as good at showing filaments themselves, but it does show the extended corona, so it gives you some insight into, for example, this helmet streamer down here. This is largely on the opposite side of the sun. How do I know? Because I don't really see it reflected in this 193 angstroms. That's an indication that it is not really on the Earth side. Again, these are 24-hour videos, and here's just 193 angstroms by itself. It is a great wavelength for showing coronal holes, filaments, active regions, and the extended corona. Next, let's talk about filaments, and yowzers, those are some serious filaments. So this one is the David Lee Roth. This one down here is the Bill Gates. And we've got some more filaments over here that could be named after living people. I mean, multiple prominences down here. Again, if you want to name filaments, do it on Twitter. Some incentive to follow us over there. Twitter, the quote social media and quote platform on which people think free speech has been fixed, which is just another representation of people believing delusional nonsense on the internet. Free speech is not fixed anywhere. Free speech is shattered and has been fully destroyed since March of 2020, even in the U.S., where we have a thing called the Constitution. Maybe that's too controversial for some of our viewers, in which case we're terribly sorry about saying the word Constitution in the video. Here's another couple of wavelengths that are good at showing filaments. If you add 171 angstroms to 193, that's a pretty sweet couple of wavelengths too. We usually show filaments at the beginning in 304 plus 193 angstroms if you want to make your own custom HelioViewer movies. That is pretty sweet. And continuing on, here's the past couple of hours from the GOES 16 SUVI. And check out the prominence up here. Now that is largely on the opposite side of the sun, so that is very unlikely to produce an Earth-directed coronal mass ejection, but sometimes the magnetic fields fling things in a crazy way. So, we sometimes see coronal mass ejections that are headed toward Earth from active regions that we can't even see on the opposite side of the sun. So it is a thing that can happen at the moment. Lots of filaments on the Earth side. So lots of filaments, lots of prominences. Likelihood of coronal mass ejections remains at nearly 100%. And a quick reminder that we don't need flares or sunspots to see CMEs. We even reported CME. In fact, we learned how to forecast coronal mass ejections around solar minimum. It was just one of those things that happens. You accidentally discover things in science when you jump down the rabbit hole. You find yourself with answers to questions not asked. So that brings us to bonus features. Starting with Satellite's community dashboard here to see charging hazards. Some minor charging hazards here of the surface variety over the Central Pacific Ocean at the moment. By the way, I had massive GPS errors yesterday on my 40-mile bike ride. It only registered about 29 miles, and it had to do with the total electron content, which we'll show here also. So here's the GOES electron flux. This is just measured at one slice of the atmosphere, the upper level of the thermosphere, known as the F ionosphere layer. The GOES 16 and GOES 18 measure that using radiography. And frankly, I'm expecting a little increase here in electron flux. So I'm actually expecting this to come up a little bit. Maybe not that high. Maybe like here. But no big argument there about the NOAA forecast, which is represented by those green boxes. There's the one-year chart to put the electron flux into context. I think we're going to break out and go a little higher here. And we'll take a look at the F layer, the portion of the thermosphere where that is measured. And here's the vibrational frequency. So this is the vibration of gases. Millions of vibrations per second there. And this will show you any wild variations that are happening at the bridge between Earth and space. If you're not familiar with that, don't worry. We'll show you the anomalygram as well. This is the anomaly in megahertz from a 30-day median. We are seeing some persistent low-frequency anomalies over North Africa, some high-frequency anomalies over Central Africa and Central South America and the Central Atlantic Ocean. I'll let that play through one more time and show the latest image, which will be at 12 o'clock noon Universal Time. There's the current situation, vibrational frequency, and there's the anomalygram for 12 noon Universal Time. Total electron content depicts the electrons between your GPS satellite and your handset. That's a run of about 12,500 miles. And of course, that includes electrons from the outer Van Allen belt, the outer plasmasphere, the inner plasmasphere, the inner Van Allen belt, and the ionosphere. Those free electrons cause signal refraction. And yesterday my GPS crapped out, so yeah, I pedaled over 40 miles and I got shortchanged on the GPS stats. So no stats there, no average speed. And I've seen GPS errors produce results that show me at a 10,500 mile per hour average speed on a bicycle. So I didn't burn up in the atmosphere. That's like Mach 12. And yeah, I didn't burn up in the atmosphere. It was amazing. I rode from Lehigh Valley to Missouri and back in like 40 minutes. That's your total electron content. That'll show you the most likely places to see GPS errors. And things are fairly orderly. We can expect them to stay fairly orderly here, especially if we do see an increase in the electron flux. Here's just the North American anomaly. That's anomaly from the 10-day average in electron content. And if there is the ability to forecast earthquakes using total electron content, we would be more than interested in doing it. We've heard channels talk about it, but nobody seems to actually forecast earthquakes. A lot of channels claim they forecast earthquakes, they just don't do it. And then they gaslight their viewers, and their viewers try to gaslight other people. And thanks for leaving a comment, General Disturbance. The electrons did not light a fire under my posterior. Anyway, there's the latest image, intensitygram and colorized magnetogram. That is still beta gamma delta class sunspot, so again, likelihood of solar flares is highest from that group. Do we have another group forming here? Nope. Do we see any umbra rising down here? Nope. Anyway, that brings us to our meteorology segment, which we will blast through here since we've got some interesting weather forecasts. And today we're starting things out with the CAPE index, which is the current available potential energy. So this will show you, well, let's talk about atmospheric physics for a quick moment. This is a perfect example of dry massive air coming down from Canada and mixing with warm moist air from the Gulf. That is the formula for this massive pressure gradient right here, which is where you get things like tornadoes. Tornadoes are caused by cold air coming down from Canada and then mixing over the central U.S., either from warm moist air from Baja, Mexico, or warm air from the Gulf, or even in some situations, both. So that's the current available potential energy from surface. It's measured in joules per kilogram. Joules per kilogram. We just shared a tweet from Tony Heller just this morning about the actual cause of tornadoes. A fact that a lot of people seem utterly ignorant about because of their claims for what, quote, climate change, end quote, would do to tornadoes. Anyway, here are the surface winds of the eastern world. There's a strong low south of Australia and also one off the east coast of the world's largest island nation. Here are the jet streams of the eastern side of the planet. Here are the jet streams of the western world, the Americas. What about the surface winds, you ask? Well, ask and ye shall receive. It's a windy time over Lake Superior at the moment. Surface winds of Europe, Africa, and the Middle East depicted here, and these are the jet streams. Next, as we zoom in closer and closer to the lower 48, we'll show clouds and fog over the Americas. That is the 3.9 nanometer infrared radiation map, by the way. Part of the NASA GOES Interactive Weather Satellite Suite. Check it out. I use it. I have them saved as favorites on my own personal smartphone weather console, so I can just click on it and then easily grab the data that I want. What's great about this one is it'll actually show you clouds and fog at nighttime. If you're doing things like going out to view the aurora, the 3.9 nanometer infrared radiation map is highly recommended. Here's our weather.gov map for the allegedly United States of America, former nation, now Banana Republic. And there are the keys. So we've got some severe weather warnings here in Texas, Oklahoma, Arkansas, Missouri, and Illinois, and also blizzard warnings in the Dakotas and parts of Minnesota. Also some hard freeze warnings and so on. If your location's lit, click your location. That is too many counties for us to cover. Weather.gov is the location, and here are some forecasts. So here is your pressure and precipitation forecast, and we've got an epic ice storm underway at the moment. So you see all that pink and purple up there around the Great Lakes. Those are epic ice storms, and be prepared for that. I mean, if you ain't got studded tires, you ain't driving in the freezing rain. You might be driving, but you'll be going from driving to sliding and riding. You'll be from driving to riding promptly. And then you'll be stuck in a ditch or something like that. And nobody will come to pull you out because they're not driving either, because freezing rain is the worst. Next, GFS forecast for positive accumulated snow depth change in inches. That's a 72-hour GFS model as well. And I figured since we have blizzard warnings, we ought to show it. So that's a 72-hour GFS forecast there. And here is our precipitation type from windy.com, one of the many features from windy.com's great free mobile app. You can view all of these stats yourself if you like. Let's take a look at the pressure here. So we've got this extended low, and it's kind of a double, but the strongest part is right over Minnesota here at the moment. And this is going to make a turn to the east. So it's going to slowly move to the east there. And some of that weather is expected to curl around and hit New England. Let's advance this a little faster here. Oh, it is still largely going to the northeast. Anyway, coming Saturday, there's a strong low moving toward Vancouver. And let's move on. Here's our lightning mapper. And we had lightning, when we did show prep, we had lightning all the way from San Antonio to Ottawa. Let's check the current situation. How about from Austin to Toronto? That is a lot of lightning. Dag, check it out. That is pretty active lightning indeed. All around the Great Lakes, We've also got some thunderstorms here in Missouri and in Texas. Next time you hear thunder, check it out. lightningmaps.org. Quite active thunder and lightning there over the U.S. We'll close things out with the U.S. Doppler radar. Clouds and fog and water vapor. So there are the full 50 states of AUSA, the allegedly United States of America. There is the lower 48 view. There is clouds and fog. And the water vapor will really show you the great pressure gradient here. You can see that colder, more massive air driving down. And then this band of dry air is making things even more extreme here because that, this air back here, this air right here is much more moist than this air right here. So this cold air is providing an impulse on this massive air, and hence you're getting massive pressure gradients. That's a great example of pressure gradients creating weather. It's essentially an atmospheric waterfall that occurs as that warmer air is unable to support the mass of that dry, massive air, and hence you get huge precipitation. That's what's going on. There's your recap. Doppler, clouds and fog, and water vapor. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. Please support the channel with a like, subscribe, comment, etc. We'll see you soon at the Smash News Network, least busted name in news, and may that solar wind be at your back.